Okay, well, I hope everybody had a good Christmas and a Happy New Year. Everything went okay. I might have got ahead of myself on the last video about the transformer, unlocking the microwave oven transformer. My first idea was to show how to make a few instruments, so I think I got ahead of myself on that one, but that information had been requested, so I just went ahead and put that out. What I'd like to do here is, since we're going to be working with high voltage, I think it would be better if you guys had a good, easy to make high voltage meter. A lot of meters won't measure over 1,000 volts, and some of these circuits we're going to be working with are going to be up around 2,000, especially for the little 4CX 250 type tubes. So what I've got here, this is the circuit. I'm going to use a 0 to 1 milliamp amp meter and 5 1 megohm resistors. Now I'm using half watt, and I know some of the sharp people out there will catch me on this. And when you add up 1 milliamp at 5,000 volts, that's going to be too many watts for those fewer resistors. But I won't be using or reading that much voltage with this meter. We're only going to be looking for maybe 2,700 at the most, and some of the transformers we're going to de-wind down to about 2,000. So there will be a total of 2.5 watts total dissipation, and I think our max at voltage we'll be using will be around 2.7 to 2.5 watts. So these resistors will handle it. We're not going to leave them in very long. You're just going to use it to make a measurement. If you can find 1 watt, 2 watt resistors, 1 meg, it would be advisable to go ahead and use them. But what I was able to find was just half watt. And got a little circuit board. We're going to mount those two. They're going to be in series, and we're going to build up a high voltage probe. Going to take apart an ink pen and make a little grabber for the end of it, the point. What you're going to want to be able to do is to grip the base of a lead or electrolytic capacitor on your power supply. So you're going to need to have a little hook and something that'll just hang and fit. You don't need a alligator clip. You're going to want to be able to put this on there with this mounted in your safety probe to where you don't have to touch anywhere near it. You just simply reach in with it and grab and let it hang there while you make your measurement. The ground lead will have an alligator clip, and you'll always hook this up first to a ground and then proceed from there to test. You touch the leads with the high voltage. This lead here is the center conductor of RG58 AU. Don't use any of the foam dielectric type. You're going to want to find some with the neoprene, solid neoprene core, and then you strip the braid off and pull this out. This wire here is good for over 3,000 volts, and it makes a real good high voltage lead. The meter I'm using is a little 0 to 1 milliamp amp meter, and with 5 1 meg resistors in series, that's going to make a full scale reading of half of whatever the readings are. So 1 would be, instead of 10,000, if you had 10 1 megohm resistors, that'd be full scale 10. What was going to be 5, the 8's going to be 4,000, 2 will be 1,000, The 4 will be 2,000. So we're going to get a reading of, we want to just right around the 4 will come up to 2,000 volts. So it'll be 1,000, 2,000, 3, 4, and 5,000 volts. But we're not going to be using anything that's going to be over like 2,700. There's a microwave oven transformer full bore is only going to give you about 2,500 or 2,700 volts. So, okay, we'll solder these up. Get them in here and lined up. Space these and give them some room for air. Of course, if you're going to use 1 watts or 2 watts, you're going to need a little bit bigger board. Whatever you have is fine. Make sure you've got some good phenolic or fiberglass board. This one here happens to be phenolic, and I've removed all of the copper. They had extra little traces around these holes, and I've just taken a file and cleaned off all the extra stuff that wasn't needed. Again, these are going to be just in series, so it's a zigzag just back and forth. I'm going to solder these when I'm done here. And then trim off the excess when we're done. Look at that, I made a mistake already. Wasn't really paying attention to what I was doing there. I was trying to make it to where the camera could see it. Wasn't watching. Okay. Yeah, that's more like it. Okay. Now we're back on track. Okay, so we got them hooked up to where it goes like this. They're all in series. Okay, like so. Now I've got a little old dip container here to use as a meter holder case. That way everything's insulated. We're gonna mount the meter in there like that. Get the hardware out of the bag here. Okay, there's one. You don't want to get on there. There we go. And snug it down. Okay. Now, I want to with the little hardware pack come these little solder tabs. I'm going to take one and see, we got to find a punch a hole in here for the lead to enter. Oop, thought I got a hold of it. Okay, there's the ground lead. Now we're going to take and mount this on here. I believe this will all fit. Get it through the eyelet first. Don't want a cold solder joint there. Okay, that looks good. Okay, we're halfway done. Make an entry point for our positive lead. This might be a little tricky getting it to finagle around there. Put that down close enough to where it won't touch against the other terminals. Okay, that part's done. Now we're finished inside here. There's what we have so far. Now, we're going to turn this old ink pen casing into a high voltage probe. It's insulated. So, take some stuff out of it here. Pull all the guts out. And leave this on. Use that for a strain relief, I think. Might be useful. Yeah, we can do that. Let's see how much we got here. Is that going to give us anything? Maybe not. Cut down a little closer. Oh, we're getting there. Okay. Let's see. That's pretty solid. Yeah, let's cut a little more away. There we go. Okay. Yeah, all right. So, that'll go there. Yeah, all right. Now for the tip. Okay, we're going to put this into here. What I'm going to do here before I completely glue this on or solder this is add a little bit of silicone glue down inside there. When that sets up, that'll hold that thing in place. And on the other end, I think what I'll do is use just a little bit of super glue to hold that green color in place. Okay, now we'll solder it. that together in there. Now this little collar I've got on the outside here be kind of like a catch. Just a little more. Okay. Add a drop of super glue to that. Okay. And clean off the excess. Now when that gets solid, see, you'll be able to take and reach in, hook that right on something and just let it hang, because you're going to have wires connected to your electrolytic caps or your diodes or something on the high voltage stack, and you'll be able to just come in there and hook on that and then get your hands off of it. Then you can fire your power supply up, take your reading, and then you're going to know where you're at. So again, with these 5 1 meg resistors, the 2 is going to be 1000 volts, the 4 is going to be 2000, the 6 is going to be 3000 volts, the 8 will be 4, and the 1 5. But like I say, more than likely you're not going to see much more than maybe mid-scale. That's about what you want. And when you dial in voltage for a 4CX250, we're going to want it hovering just right over that 4 mark, which will actually be 2000 volts. Ohm's law is the 5 megs, and if you have 5,000 volts divided by 5 meg, you're going to come out with 1 milliamp. So you just divide the voltage by the ohms, and you're going to come out with a milliamp. So again, the 2 will be 1000 volts, the 4 will be 2000 volts, the 6 will be 3. And we're just going to want to do between the 4 and the 6 when we get going. Okay, hope that save you from having to buy one of the higher voltage, like a Pomona high voltage probe. Those things are very expensive, and just this simple thing here would be able to give you test equipment, and you can measure your voltage when you're testing your power supply to get it up to whatever voltage you want. Again, it's not really intended to leave it in line. If you wanted to leave it in line, then I would suggest you use 2 watt 1 meg resistors on that, so that over time they'll be able to dissipate heat, and they won't overheat or change value on you. You don't want to use carbon. If you can find them, it would be okay. I would say if you could find a brand called Allen Bradley. They're getting really hard to find these days, but Allen Bradley 2 watt carbon composition resistors would work okay in this instance. But these that I use are just a metal film. Should be able to find them on eBay. When I looked, nobody had any 1 watt resistors. They just had the half watt. But maybe, you know, with keep looking around, you might be able to come up with 1 watt or 2 watt resistors, which would probably be better to use than the half watts. But if you're only going to make a short term voltage measurements just for a minute or so, the half watt resistors won't overheat on you before you're done taking your readings. So have a fine one, and our next video we'll get back to working with transformers. I think the next one coming up will show how to take windings off of a microwave oven transformer, so we can take the voltage down from 2,700 volts. We're going to remove windings so that it'll give you 2,000 volts or just slightly above. 2,100, 2,200 is about right for a 4CX250 in that category. And if you had other tubes that use less, why, we're just going to take more turns off the transformer, and I'll try to show that in the next video. Okay, thank you. Thanks for watching. If this gives you any ideas on how to maybe save some money and it helps you, please like, and we'll see you in the next video. Thank you.